All right, welcome back. Integrated Math 3 students, we are working on practice number 6 where we're talking about function intervals. This is the homework section. We want to answer each of the following regarding intervals, and number 1 just says over which interval or vols, it may be more than one, is the function decreasing. And here we have a parabola. And it looks like if I were to draw a line right here, a vertical line, I would split it into two. It's increasing on the left, then it starts decreasing on the right. And that's what it wants to know. Where is this function decreasing? Well, starting at positive 1 on the x-axis, on and on till the end of time, or positive infinity, this thing is decreasing. So from 1 until infinity, we are decreasing. Cubic function, this one wants to know where is it increasing. Okay, it looks like it's increasing here. Then it starts decreasing here, and then increasing again. So we're going up, then we start going down, then we start going up again. So I'm going to draw a line through those peaks and valleys. Those are known as maximum and minimum, maxima and minima, relative and extrema. We'll talk more about that in detail in the future. But as for now, this line looks between -1 and -2. So I'm going to say that's x equals -1.5. And starting out at negative infinity until I get to -1.5, this graph is increasing. But there's also a second interval where it's increasing, this one. This appears to be between 1 and 2, so positive 1.5, until we go to positive infinity, it is also increasing. Okay. Number 3, over which intervals is the function increasing? This is an absolute value function. Looks like it's going down and then it starts going up. So right here, right on the y-axis is that split, and that's where x is 0. So from 0 until positive infinity, we're increasing. Number 4, over which intervals is the function decreasing? If you look very carefully at this one, it never decreases. It's always going up, right? So I'm going to say never. This does not decrease at all. There's no point where it actually changes direction like this one did earlier, where it started going down before it went back up. This one's just always going up. All right, we want to use a table to sketch a graph of each function. Then we want to discuss the intervals in which it's increasing or decreasing. So I'm going to do an XY table for number 5. Plug in a couple of points, -2, -1, 0, 1, and 2. And I'm going to start plugging them into the function to see what I get. If I take -2 and plug it in for x, -2 minus 1 is -3. -3 to the second power actually makes positive 9. If I take -1 and plug it in, -1 minus 1 is -2. -2 squared is positive 4. If I plug in 0, 0 minus 1 is -1. -1 to the second power is positive 1. If I plug in 1, 1 minus 1 is 0. 0 squared is 0. And if I plug in 2, 2 minus 1 is 1. 1 to the second power is 1. So I think this gives me a general idea what this graph looks like. -2, 9 would be to the left 2 and up 9, so somewhere up here. -1, 4 would be to the left 1 and up 4, somewhere in that neighborhood. 0, 1 would just be up 1. 1, 0 would be to the right 1 and not up at all, sitting there on the x-axis. And 2, 1 would be to the right 2 and up 1. So there it is. I know this is quadratic, so it's making a parabola. And it looks like the vertex is located right here on the x-axis. So I'm going to draw a line right through there. To the left of that line, this is decreasing. And to the right, we are increasing. So from negative infinity until we get to 1, from negative infinity until positive 1, we're decreasing. Then as soon as we get to positive 1 and start moving towards positive infinity, the graph's going up, so we are increasing during that interval. Cool. Number 6, this is a linear function, x plus 3. Okay. I'm not going to make a table of values for this because I already know what this looks like. It has a y-intercept of 3 and a slope of 1. So up 1 and right 1 every time. It's going to look something like this. And so it's always going up. It is always increasing. So from negative infinity until positive infinity, we are always increasing. Okay. I'm going to leave you guys to do number 7. Understand that this is a quadratic function, so again, it's going to be a parabola. Feel free to use a table of values, plug in some points, see if you can figure out where it stops increasing or decreasing, and etc. And I hope this helps, and I will catch you guys next class.